Hi everyone, welcome to a new video. We're introducing, now that we've looked at logs and how they relate to exponentials, we are 3, 2, 1. Hi everyone, welcome to a new video. We've introduced logs in the last few videos and looked at how they relate to exponentials, and we've also done a little bit of practice with sketching some of these log graphs. What we're going to do now is establish a few what we call log laws. So we're going to run through a series of these laws, and like we've done a lot on this channel, we're actually going to derive them so you can actually understand that these aren't just arbitrary things we've pulled out of nowhere. And we're also going to look at the reason a lot of these work is based on things we know about exponentials. So every single one of these laws relates to something we know about the laws of exponents, which we've talked about before. Now, this first one we're going to go through together so you can kind of see how we can go about deriving these. And then I'll give you guys a chance to pause for some of the later ones and see if you can actually derive these yourself using the same logic. Okay, so what we have here is the first log law, which says that the log of any base a of some product here, x times y, equals to log a of x plus log a of y. Now what we're going to do here is we're going to relate this to another law where we saw some kind of multiplication first being the same as addition, and we're going to revisit this law of exponents. So we said ages ago when we first looked at these index laws, we said that if we have some base a and we multiply it by the same base to the power of n, we're going to get a to the power of n plus n. So you can kind of see like a similar pattern happening. There's a product here, there's a product here, there's an addition here, there's an addition here. Now we're going to look at how we can relate these to make a link to these. Now, I have two of these things here, a to the power of m and a to the power of n. So let's just give those their own name. Let's just call this one, to relate it to our formula here, let's call one of these x and the other one y. So let's call a to the power of mx and a to the power of n y. Okay, so we're going to set up a couple more equations. So we know that x is going to equal to a to the power of m, and y is going to equal to a to the power of n. We're just giving these names and setting up some kind of equations and relationships between these two, which is going to help us to derive this formula, or this log law, I should say. Now, we remember based on logs that when we have things in this particular form, we can rearrange them, and we can express exponents, rearrange them, and write them as logs. So we've covered this many times in previous videos, so I'm going to fly through this a little bit quicker. I have a base a and a power here. So we can rewrite this x equals a to the power of m as log to the base a of x, my answer, equals to the power on the other side. We can do the same with this one on the right. We can say log to that same base of a of y equals to the power n. So not too bad so far, hopefully. We're just recapping basic things we know about log and exponential form. Now, from this equation, we can say that since we've given a to the power of m the pronumeral x and a to the power of n the pronumeral of y, we can say, once again, just to reiterate, that x times y is going to equal to a to the power of m plus n. This is from this bit up here. Now, I've just replaced this, so x times y equals to a to the power of m plus n. I've just restated this formula up the top. Now, what we're going to do here is, just to give us plenty more room, now that we have something like this, we can rearrange this into log form, because this is in exponential form. So let's just rearrange some things. We have, once again, a base and a power and some kind of answer on this side. So we can rewrite this thing as log to the base a of xy equals to the power on the other side, m plus n. So now that we have this, let's just revisit what we said to be m plus n again. Because from what I can see up here, I've got the left-hand side of my formula here, down the bottom. Now I just need to somehow relate this right-hand side, m plus n, to this right-hand side up here. Well, I can see from how we rearranged these that m corresponds to log to the base a of x, and n corresponds to log to the base a of y. So I can just substitute these things in for m plus n. So instead of m plus n, I'm going to replace these with log to the base a of x plus log to the base a of y. So I get this thing here. My left-hand side stays the same, and the right-hand side I get log to the base a of x plus log to the base a of y. So using what we know about exponentials and manipulating this a little bit, kind of changing from log form to exponential form, we were able to show our log law up here. And in the next video, we're just going to look at how to actually apply these. So all we're doing now is just deriving and understanding these laws. Now, this next one here states that log to the base a, this one here. The second log law tells us that log to the base a of x divided by y equals to log to the base a of x minus log to the base a of y. Now, I would encourage you guys to pause here and have a go at deriving this on your own before checking, because this little problem solving exercise is going to help you just understand how these work, and it's also just a pretty good mathematical quality. As you can see, these take a little bit of creativity to prove. So if you'd like to, feel free to pause, but I'm going to go through this one now, and it's already written so we can move through it a little bit faster. So to find this one, we're relating an exponential law or an index law that we have established before. Once again, we notice there's a division here and a minus here. That reminds us of our law of exponents, which tells us that a to the power of some power m divided by that same base, a to some different power n, is going to be a to the power of m minus n. So I'm going to do the same thing here. I'm going to set a variable x to be equal to a to the power of m and set a y to be equal to a to the power of n. Now, once again, same as the previous example, we're going to write this in log form. So I'm rearranging these two here into these ones you see below. So I can write m, this power, as equal to log to the base a, the base x, and n equals to log to the base a of y. Now I've just rewritten my thing up here, a divided by a to the power of m divided by a to the power of n. I've written this thing, but I've just replaced a to the power of m and a to the power of n with x divided by y, respectively. And that equals my right-hand side up here. Now, doing that, I can rearrange this now to write it in log form. So my base a goes down here, my power, m plus n, goes over here, and my thing on the left-hand side, my answer, x over y, goes here. So I've just rewritten this from exponential form and changed it to log form down the bottom. So once again, we notice that since I have the m minus n on the right-hand side on their own, over here, I can now just substitute in log to the base a of x for m and log to the base a of y for n. And I get my log law here. Log to the base a of x divided by y gives me log to the base a of x, minus log to the base a of y. So we're doing it in a very, very similar way. Let's move on to the third one. We're given here that log to the base a of x to the power of n is equal to n times log to the base a of x. Now this one's slightly trickier. Once again, you can pause this and have a go on your own, but I'm going to run through it now. So I'm using a law that we learnt in when we did index laws. This is that when I take a number a to some power m and raise it to another power of n, I get the same base with those powers multiplying. Now what I'm going to do here, I only have one, sorry, just zoomed in randomly. I only have one thing to some base a to some power, so I'm just going to let x equal to a to the power of m. Once again, it's very similar to what we were doing before. We're not really doing anything new here. So since I've set x to equal a to the power of m, once again I can rearrange this and write it in log form. So very similar, I just rearrange my thing in its exponential form and I write it in log form. And I'm just revisiting this formula, this one up here, and I've just written it, but instead of having a to the power of m, I've just replaced this with the x here, substituting in that one over there. Okay, now that I have this, I can write this in log form. So I can say that log to the base a, because that's the base that goes here, to the power of m times n, the power goes on this side, is going to be, I'm going to put that answer thing over here. So once again, we're just rearranging from exponential form to log form. And I can pretty clearly see here that since I've set m to equal to log to the base a of x, this right-hand side just becomes n times log to the base a of x. So once again, we have been able to derive the formula over here, that log to the base a of x to the power of some number n, I can rewrite the log law by moving the n in front, and that gives us a product of n times log to the base a of x. So this is the same as the formula the log law that I introduced up here. Now we're almost done. There's just a few more, and these ones are actually a little bit easier to derive because they're just based on properties of exponentials and the index laws we talked about before. So we have a few more properties of logs, which you can actually probably do these quite easily if you want to pause and have a go. All of these just require us to understand how to go from log to exponential form. Now, this thing here tells us that if I have log to any base a of the number 1, the answer will always be 0. Now the reason that is this is just a property of logs based on the properties of exponentials that we talked about ages ago. Because if we rearrange this formula, I have my base a to the power of 0 equals to my thing over here. So we talked about this exponential law where anytime I raise a number to the power of 0, I get 1. So just rearranging this from exponential form to log form, I get a brand new log law, which is that when I have some log to the base a of 1, it's going to give me 0. There's just two more I want to talk about in this video. They are very, very similar. If I have some log to the base a of that same number, a, it's going to equal to 1. Now, once again, this is the case because of the exponential law we talked about before, where if we have a, the base, to the power of 1, it's going to just give me that number. Anytime I raise a number to the power of 1, it just gives me back that number. So anytime we have log to the base a, we have some base and the same number. If these two are the same, it's always going to give me 1. Now, our final log law is that when we have log to the base a of 1 over x equals, there's a couple of steps to this, but this is going to equal to negative log. Actually, let's just write it like this. Negative log to the base a of x. This is our final log law. Now, there's two ways to actually prove this. You can pause it and have a go on your own, but one of the ways is we can notice that this thing on the left-hand side, we can write this in a different way using our log laws. So, if I have a log to the base a of 1 over x, I know based on the second log law that when I have numbers dividing by each other here, I'm going to get log to the base a of 1 minus log to the base a of x. So there is just another way to write this. Now, based on what we talked about previously, when we have log to the base a of 1, we just think of this as 0. So this thing on the left hand side is the same as 0 minus log to the base a of x, and that just gives me negative log to the base a of x. So this is the first way to do this. You can try another way if you want to pause the video and have a go. But another way we can think of this using these same log laws we talked about is to consider how we can write 1 over x in a slightly different way. So if we have log to the base a of 1 over x, what we learned about our indices and our index laws ages ago is that we can write 1 over x as x to the power of negative 1. Now, since I have log to the base a of x to the power of negative 1, our third log law that we talked about tells us that we can bring this power up the front. So when we have my number here, x to the power of something, I can bring that power in front, and that multiplies by our log a of x, log base a of x. So this just brings in front negative 1 times log to the base a of x, and I don't have to include the 1 here. When I have minus 1 times a number, that just gives me that number as a negative. But that brings us to the end of the video. If you've made it all the way through, I really appreciate it. This is how we can derive and understand how we got these log laws. Now, at the end of the day, when you're doing questions, you won't need to really know how to derive them. You're just going to be applying them based on the laws that your textbook gives you. But hopefully this video gives you a little bit of the intuition as to why it works, and it ties in to what we've been talking about in the past, which is this really heavy relationship between logs and exponentials. And we actually use these index laws, these laws of exponents that we talked about years ago, and we can apply those to understanding logs. But that brings us to the end of this video, and in the next one we're going to be using some of these laws to figure out some questions. Thank you so much for watching, and I'll see you next time.